So hi everyone, welcome to the recording for the XTC101 Intro to Testing. My name is Glenn Stevens, I'm going to be your instructor today. Now in order to do this particular class, you'll also need to download the course materials from university.xamarin.com. And you'll need to go to the courses page. And do a search for the XTC101 and download the class materials here. There will be a few exercises that we will be going through, so make sure you have those files handy. What we're going to do today is introduce you to the foundations of creating tests for your mobile applications using Xamarin Studio and NUnit. So this is an entry-level class where we're going to take you through a lot of the fundamental concepts behind testing so you can use it effectively in your own applications. Our objectives today are to give an introduction to testing using the Xamarin tools to test not only the internals of your application, but also understand some of the testing strategies that you can apply as well. We'll explore the different kinds of tests that you'll use while developing an application. And by the end of the course, you'll understand the benefits and practicalities of testing, some of the nuances about testing against your mobile applications, and how to apply it in your own applications too. So let's start by looking at the importance of testing. In this section, we'll have a look at the importance of testing, we'll look at mobile-specific issues, and we'll introduce you to some concepts outside-in testing as well as inside-out testing. So who hasn't had any bugs in their software? And I think while you're listening to this, you're probably laughing or just going, that's absurd. Of course I've had bugs in my software. Because really, there's not a software developer that hasn't had bugs in their code at one point during development. And we see examples of this in many software applications, from the Windows blue screen of death to the bugs that weren't bugs at the time but became bugs over time due to environmental changes like the Y2K bug. We often see changes or differences in the environments, misunderstandings of the purposes of software, or even operating system upgrades that affect how an application performs. Now, to make sure that we build the highest quality apps, we need to test our apps as thoroughly as possible. And today we're going to discuss testing and demonstrate how this can be applied to mobile devices using a range of tools. But before we do that, let's have a look at some methods of traditional testing and mobile-specific issues. So let's stop for a second and think about how you may have tested applications in the past. Now, you'd get your applications to a state where it was nearing completion, and then you'd manually work through the app and use the application to see that the application behaved as you expected it to. And you may have even handed it to someone using the classic hallway test to see that they could use the app. But these kinds of behaviors aren't really repeatable, and it depends on the level of testing. The testers may be working from memory, they may be only testing the way that you see the app, or they see the app. So they've got this vision of how the app is supposed to be, but that may not be the complete picture. And that might mean that you're only testing really a subset of the total app, and you still have gaps in the testing strategies. But as the number of features and the number of devices grow, it becomes really impractical to manually test your applications, and it's very labor intensive too. So instead, we can actually automate our testing to make sure that we're testing not just the new things that have been added, but also the previous functionality in our app as well. So it's important that we create our application and take it through the application lifecycle so we can create acceptance tests, and as the application grows and expands, we can make sure that the application keeps in line with its original functionality. Now, mobile application development is still software development, and your apps will have the same issues that traditional apps will. However, mobile phones bring with them unique challenges that you may not have considered if you're coming from a desktop or coming from a web-based development environment. So you'll often find that your users will differ by devices. They'll differ by network connectivity, the availability of services and capabilities on a device, and a range of other factors that you may not have even considered. For example, an Android app that targets Android version 2.3 devices and above will be supported on roughly about 8,000 different device variations due to the large number of devices in the Android market space. And that number is actually coming from the Google Play Store when you upload an app. So in addition to the number of devices, you'll often find that devices vary in screen sizes, in resolution. So not only you should test your application on both phones and tablet versions of the operating system, you'll also need to test on a range of device sizes too. Another thing is that mobile application development is often done in an office, and as a result, you might be testing your apps in a situation where the application has full network connectivity, full battery, and uninterrupted by other applications or phone calls. But the reality is that mobile phones lose connectivity. It's part of their day-to-day use. People will be using an app on the train as they're going through a tunnel, and they'll go in and out of network connectivity. And you'll need to respond to that in your development and also in your testing too. So I like to encourage people when they're testing network applications to actually use the application outside, go into areas where there's poor network connectivity, or find a mobile network provider that doesn't actually have great access in your area and see how your application is going to respond there. Likewise, your application should expect to be interrupted by phone calls or text messages or other prompts that appear from time to time. So making a phone call to a device running your app can actually check to see if those aspects will still function when you receive a call. In addition to that, operating system updates will be released, and the application that you had working in a previous version may no longer work after the update's applied. There might be changes to security, privacy, or user interface aspects that fundamentally change how your application works. You may have seen several examples of that with iOS. Originally when iOS came out, there was the Contacts API, which allowed people to get access to that, and then some apps were being unscrupulous and sending that contact information up to their own servers. So there was additional privacy calls wrapped around the Contacts API, and things like that happen from time to time. When you start creating automated tests, one of the questions that come up is about the correct place to start testing the code. So is it better to come up with an initial low-level design and then start running tests from the lowest component in that design and progress to the high-level components? Or should we start with a high-level functional test at a user story level and then drill down into the low-level tests as you flesh out the user workflow? And the short answer is that either approach is possible, and it depends on your team's coding preferences. So let's actually take a look at both styles. And it's worth noting that the inside-out testing actually refers to where you start testing. So we're testing from the internals of the application out through the layers to eventually the user interface. And outside-in testing actually tests from the user interface back into the internals of the application. So let's have a look at the two styles, and we'll start with inside-out testing. So inside-out testing, commonly known as unit testing, performs tests on the individual classes and functions of the application independent of the user interface. So you'll actually see on the right-hand side here that there's many different areas of testing your application. There's model classes, business layers, service layers, user interface layers. And each of these layers need to be tested as part of your application development cycle. So during today's labs and presentations, we'll be going through the techniques that you would use to test these layers. So inside-out testing refers to testing your code first. It's very developer-centric and means that you start testing the internals of your application and continue to test through the layers. And this is achieved by writing unit tests. And unit tests are tests on software that determine if parts of the application are fit for the purpose that they were intended. And they work by simulating scenarios of the classes that are used in the application, along with real or simulated data under a number of scenarios to check that the outcome, again, matches what was expected. And unit tests are written against a test framework that allows a collection of tests to be executed together so you can determine the quality of the overall system. So the unit test that's demonstrated on the slide at the moment is showing the phone translator class from the phone word application that you may already be familiar with at Xamarin University. And that's converting a phone number like 1855 Xamarin into its numeric equivalent. So here we know the expected outcome, so we can check to see that the expected outcome matches the actual outcome. For .NET developers, this normally consists of writing tests in a framework called NUnit, where we can write code to test many of the layers within an application. So we'll look at how we can write unit tests in the next objective. So that's what we'll cover briefly on inside-out testing. Let's have a look at outside-in testing. Outside-in testing, also known as acceptance testing, checks that the final application as a whole conforms to the original specification. And you can see you're really testing the application at the user interface layer. And in the same way that we need to write test code that tests whether our application works the way we expect through unit tests, the ultimate test, I think, is really whether it works the way our users intended. And this is referred to as behavior-driven development. And behavior-driven development formalizes the experience of some of the best practitioners of automated testing. Behavior-driven development, or BDD, formalizes the experiences of some of the best practitioners of automated testing. So business and technical staff together develop a set of tests or acceptance tests that determine if the application is acceptable. So Cucumber is a popular tool for implementing behavior-driven development by writing in a business-readable syntax called Gherkin that can eventually be processed by a software development language. We're able to develop robust tests that validate that we're building software deemed acceptable by the end users. And the text that you see on the screen is an example of a Cucumber feature. And Cucumber is a framework for Ruby that allows you to write software specifications as well as a tool to execute those specifications. So in order to work with mobile devices, Cucumber uses Calabash to allow you to test mobile devices. Calabash is an automated user interface acceptance testing framework that allows you to write and execute tests that validate the functionality of iOS and Android apps. So if you're writing enterprise apps, your business analysts or customers who are affected by the software define those scenarios in collaboration with you. For consumer level apps, this might be a product manager or the result of discussion with typical users or customers. So even if you're not using the system to include the automated test aspects, you can actually still gain a lot of value by having clearly defined steps created using Cucumber. And this is covered in our XTC102 class, Introduction to Calabash, which goes into more detail on the topic. So if you're interested in that particular mechanism, you should register for the course. Another alternative course you may look at registering for is the Introduction to Xamarin UI Test, which covers automated testing, but using C# as a backend. So there's a range of benefits and drawbacks to using inside-out testing versus outside-in. So inside-out testing allows you to test the internal aspects of the system, but the problem with inside-out testing is that the user interface is barely tested at all. You may be testing it if you're using view models. If you're unfamiliar with the concept of view models, we do have a class, MVVM, in Xamarin Forms, where we discuss that in a bit more detail. On the flip side, outside-in testing allows you to test the user interface, which is what really the application will be signed off on. But it doesn't really test the unexpected edge cases that you'll see in the application. Having the right combination of inside-out testing and outside-in testing is really going to help your app have as much quality as you can. And you know you're going to have a robust system. Okay, so that's going to take us to our first flash quiz of the day. As this is a recording, we'll use the honor system. I'll ask a question, pause for about 10 to 15 seconds, and then you can answer it and see how you went. All right, let's start with the first question. Question 1, what are some of the issues with testing mobile apps? Just choose all that apply. So we have device fragmentation, B, network connectivity, C, access to services or capabilities of a device, or D, interruptions. And the answer here is all of the above. So question 2, outside-in testing refers to A, testing the application outside using Wi-Fi and then going indoors, B, testing the actual features of an application, or C, testing that the user interface looks right. And the answer here is B, testing the actual features of an application. So that's the end of the first objective. We've had a look at the importance of testing, some issues specific to mobile, and also introduced the concepts of outside in and inside out. So let's move on to the next objective, comparing the types of tests, and also creating unit tests with NUnit. So what is unit testing? And unit testing is the ability to test parts of your application as a series of small tests to determine that your application or system works as it was supposed to. A unit test check parts of the application that may be either a single method, a class or interface, a series of classes that work together, integration to an external service or data source, or checking that the application will work against previous versions of the application. And all of those individual types of tests, some of them have their own names, and we'll actually explain those as we go through. But unit tests are also designed to be modular and also to work independently of other tests. And as a result, they should be repeatable and fast so that you can run the same tests without changes, and you should expect that you would receive the same result. So in this objective, we'll look at the types of tests, we'll look at the basic mechanics and process you go through when writing unit tests, and also working with NUnit, which is a very popular framework for unit testing, and also the one that Test Cloud supports too. So there's many different types of testing that you can perform on your application. Each one has its own purpose. You can see down the bottom we've got unit tests, and unit tests will actually make up the bulk of your tests. We also have an integration test, testing the combination of classes that work together. We have regression tests, checking that your application will work against previous versions of your application. Very useful in the mobile world, especially when you're doing apps that update. So there's also acceptance tests and user interface tests. We'll start off with the unit test. And a unit test takes a small unit of the application, which is typically a method, isolates it from the remainder of the code, and verifies that it behaves exactly as you expect. So you can see the calculate tip method. So we've got some possible calculate tip values. So if we pass in 15%, it should result in the proper total. Likewise, a 20% tip would result in the proper total. If we supply a negative tip, then we should actually expect an exception to happen there. So we're testing not only the situations that work, but we're also testing the situations that shouldn't work as well. Now let's have a look at the integration tests. And integration tests verify that the classes work together as expected. You can see on the slide here, we've got a student class and also a course class. And the integration test is actually seeing that those classes work together. So you may be performing tests such as adding a student to a course and making sure that that course lists that student in the roster. You might be checking that the number of students in that course has increased. You may be checking things like receiving the list of students from a particular course as well. So you're testing both the student class and the course classes together to verify the combination. And we also have regression tests, and regression tests check that older versions of a class will still work properly as new changes are made to the application. So this type of testing is particularly important for public elements of your system or extension points. And you can see here on the right hand side we've got a course class, and we've got some unit tests for version 1 of the application, and we've also got some unit tests for version 1.1 of the application as well. So we write tests for the particular version, and we can see that our previous code would work as well. Regression tests are actually quite important in the mobile space, especially if you're doing things like connecting to a REST service, for example, to extract data. You might actually find that your application updates, or there's updates on the server, and there'll be a period of time where your devices haven't quite updated. So you've got new apps and old apps trying to connect to the same system. Situations like that really force you to make sure that your current app works, but also your previous app works. Now finally, let's have a look at acceptance tests. And acceptance tests ensure that the finished product conforms to the original design or specifications and is fit for the purpose that it was intended. So this is how the application normally gets signed off by the customer. And the acceptance tests really check the application works based on the specification. So this is the kinds of tests that you might create using Calabash, or you might create using Xamarin UI test to make sure the application performs all the tasks that it's supposed to according to the specification. Here we've got a great quote from Martin Fowler, which just summarizes the testing process with unit tests all the way through to acceptance tests. Reading through it, you would have unit tests for individual classes in the domain and database mapping layers. In most of these unit tests, you might not even connect to the database. You'd stub the database out. And that actually looks at the point of making sure that the unit tests are fast. You want your unit tests to run extremely quickly so you can get back to writing the code. If you've got a unit test suite that takes 20 minutes to run, obviously that's going to affect the amount of code that you can write within every hour. So you want to make sure it's as efficient as possible. So doing things like stubbing the database out or simulating what a database or network call might be doing allows you to do that. So acceptance tests test the system more as a black box and test more end-to-end across the system. But with the functional acceptance tests, which go end-to-end, you'd want everything connected. So you might use a system like Calabash here, or you may even use a service like Test Cloud. But modern unit testing requires that your unit tests exist in an existing framework. And these frameworks allow for testing a number of unit tests together and then monitoring their output. And there's many unit testing frameworks available for .NET developers, but the one we're going to look at today is NUnit. And NUnit includes support for running tests in a host and can be used to test the functionality of our mobile applications. And there's also support for integration into IDEs such as Visual Studio or Xamarin Studio. So while we're using NUnit for today's course, you'll often find that other unit testing frameworks such as MS Test and XUnit have similar mechanisms and styles. So while there are other unit testing frameworks available, Test Cloud and Xamarin Studio currently only support NUnit, so we'll be utilizing this going forward. And you'll find that unit tests take particular steps when executing. So here I've got a unit test on my screen, and you'll find that it goes through 3 phases: arrange, act, and assert. So the arrange part, that first step, sets up the test to simulate what the test needs to do. That's arrange. And the next part is the actions or the operations will be performed, and that's the act part. And then we'll check that the results of the test are what's expected, and that's the assert part. So another important aspect of a unit test is naming the unit test itself. So when naming classes for your unit test, you should ideally have one class that represents the test for your class. So ensure that the test name describes what it is that you're testing and under what conditions. For simple tests, you'll find that this works well enough, but for larger tests, you may want to restructure so that you've got nested classes that deal with the larger complexity. But tests should ideally be named so that it's possible to discover what's being tested and what the expected behavior is. And if a test should fail, then it's a very easy way to determine what went wrong and where. So a very common pattern for naming your tests are to use the unit of work, in this case PERT test, check the state under test, in this case we're checking for equality, and look for the expected behavior. So the expected behavior here should be true. Now, if you're doing unit testing with Xamarin Studio, which I expect that you are, you'll actually find that there's some very useful debugging features in Xamarin Studio that you want to enable. So let's go to Xamarin Studio for a second. And we'll just go into Xamarin Studio into Preferences. And we'll scroll down here and we'll select the source analysis. You want to make sure that you've got this enabled, the Enable Text Editor Unit Test Integration. And this actually allows you to unit test directly from your code. So you'll find a little dot next to your class names and your method names where they're actual unit tests. Now, the other thing that you may want to do is you may actually want to use some of the view options. Now, to do that, I'm actually going to need a new unit test library. I'm going to create this NUnit library project here. I'll just put this on my desktop. And I'm just going to call this project PERT Calculations. This will become part of the demonstration for a bit later. I'll hit OK there. And you'll often find that if you want to look at some of the testing panes, you'll need to go to View, select Pads, and then there's the Unit Tests option. That'll pop out the list of unit tests on the right hand side. Or there's also the test results, and you'll typically see that pop up from the bottom. So once you run unit tests, you can see those details here. Another great approach to using this is to use the unit testing layout. So that'll actually take you where both of those are visible and locked in. And then you can just basically run the tests as they are there. We'll have a look at the execution a little bit later and see the results underneath here. So one passed, there was no problems. And also after we've run them, we can see the highlighted dots in our code editor because we enabled that source analysis option. So you can click on those dots and actually run them in line. So you may only want to run a particular test, or you may want to run all the tests within a class. So that's actually going to take us to the first part of today's class. So this is going to be a demonstration of the first technique that you'll find in your lab files. And we're just going to create a very simple unit test. And in fact, we've already created the NUnit library project. And we did that by using the file new template. So we did a file new solution, select NUnit from the C# option, and selected NUnit library project. So we've got that there. We've got PERT calculations. This is going to be our test package. And I'm actually going to write some tests here. I'm going to add a new project. I'm just going to create a new portable class library. And I'm going to call this PERT estimates. And just hit OK. And I'm going to call this class estimate. And I'm really just going to have a very simple method that basically calculates the estimated time for a particular task. This is using something called PERT, which is an old US military way of calculating the expected time for a task. So you would typically pass in the likely amount. You would pass in the best case. And you would also pass in the worst case. And from that, you'd actually apply the appropriate calculation, which is really just multiplying the likely amount by 4 and then adding the best case and the worst case amount, and then dividing the total by 6. So that's our very basic class. I'll just rename this file as well using one of the inbuilt refactorings. So there's our class that we can call. So let's go back to our unit test. So we've got this PERT estimates unit test. And we want to do a few things. I'm just going to clean up the parentheses from the code generation. I don't really need those. But I want to call this an appropriate name as well. You want to use the aspect under test here. This will be PERT calculations. The bit we're testing, checking for equality, and also the expected outcome should be true. So here now, our test case, that was actually supposed to be the method name. The class name is normally what you're actually doing within that class. So PERT calculation tests. So within our method, we have those 3 aspects that we want to do. We want to arrange, we want to act, and we want to assert. So the arrange is where we do all the setup for the test. So in this case, we need to define what the appropriate values are that we need. So I do have a particular test case that I know is accurate, so I'm going to use that. So I'm going to say the likely amount is going to be equal to 20. I'm going to say that the best case amount is going to be equal to 12, and the worst case is going to be equal to 40. But then I know my expected outcome should be equal to 22. So there's my arrange part. And then I actually act on those values. Now, in order to use the portable class library, I will need to add a reference to that library within my test solution as well. So you'll find that the NUnit projects are really just class libraries. and they've got the NUGET package for NUnit added in. So if you're using Visual Studio, you can actually create the NUnit projects in that way too. There's plenty of wizards that you can find and in the tools and extensions that'll add NUnit support into Visual Studio if you don't have NUnit support in there already. So let's go through the act part. So here's where we want to actually get the actual outcome. And this is going to use the estimate class. And we'll calculate that value. We'll pass in the likely amount, pass in the best case amount, and the worst case amount. And then we'll do the assert. The assert is really checking that the expected outcome matches the actual outcome. So I'm going to use the assert class here, which is a built-in class of NUnit. And I can use particular methods like r=, and I'll pass in the expected value and pass in the actual value. Okay, and the assert class will actually raise an exception if that condition isn't met. So what you'll find with unit tests is that unit tests will actually run fine, and if there's no exceptions raised, that means the unit test was successful. But anytime an exception is raised, well, an uncaught exception is raised, then that means the test fails. So in the case of the assert class, we're checking for equality, and if the equality doesn't happen in this case, you'll find that the test will fail. So you'll see there's a series of other methods that we can use as well. And we'll go through some of the more popular ones a little bit later. So here's an example of a very simple unit test. So let's go ahead and run this. I can use the unit test pane on the right. I can just click the run all. That'll compile and build the project. If there's anything wrong, it'll tell me. So here I can see the test results with the PERT calculations is that I've had one test, which is good. And if I change the expected outcome here, rerun the test, I should actually see those tests fail. You can see it turned to red there. But obviously you want all your tests to be green to indicate that your apps are the appropriate quality. Now from time to time you'll find that your tests will actually be wrong. I mean, after all, they are still code. So you will need to debug your tests and step through it line by line. So you can just put breakpoints as you would put breakpoints in normal code. Click on the dot next to that method, and then just select the debug option as well. And that way, when your tests are running, you can step through the code, you can hover over the items, see what's happening, and get an idea of where you need to fix your test code. So hopefully that gives you an overview of how you can create the unit test. At its core, they're fairly simple. It's really that arrange, act, assert mechanism that you need to keep in mind. So let's have a look again at creating a unit test with NUnit. So each method that wants to be a unit test is decorated with the test attribute. So we need to make sure a few things are happening. We want to make sure that we're following an appropriate naming convention for the test methods. And we also want to use the assert class towards the bottom here as well. We want to make sure that we're actually performing a test. So if we're not doing any work that actually could potentially raise an exception, such as using the assert or actually raising an exception internally within the application to indicate an error, then we're not actually performing any tests at all. So successful unit tests execute and raise no exceptions. In order to make sure that you're actually performing tests, you should have at least one assertion using the assert class, and make sure that your class does not throw any uncaught exceptions. But that assert class is very useful. So the arrange and act aspects of a unit test use your C# skills and knowledge of the classes that you're working with. And the assert class allows us to test the functionality of our application to a fine degree, and has a series of static methods that perform the tests. And the test will normally take enough parameters to check that the test is valid, and then has an optional message to display in the event that the test is unsuccessful. So you can see examples here like r equal. That's the one that we used in the sample test, but realistically the assert object is just checking a condition. And you'll find that you'll be doing things like checking that values are not equal, checking that a value is true or some condition is true or false. And there's a range of others that you'll use. So these ones on the left-hand column are actually the ones you'll probably use most often. But over time, you'll become very familiar with the assert class as you create more and more unit tests. Now, in addition to NUnit, there's also a framework that ships with Xamarin called NUnit Lite. And NUnit Lite is a framework that allows you to test your device-specific code on your iOS and Android simulators or emulators. So NUnit Lite is based on the NUnit framework and has the same mechanics available for your application. You'll actually find the templates in the iOS and Android tree structure of the template wizard. For iOS, you'll see the iOS unit test project, and for Android, you'll see the Android unit test project. And go through the process of actually creating an NUnit Lite project. So I'm going to right click on my PERT calculation solution, add a new project, and I'm going to select an Android unit test project today. But it's a very similar process for iOS. So I'll just have a project name, test Android capabilities, because often you'll use NUnit Lite to test things about your application that are very device specific. So obviously you can't write unit tests to check that a particular sensor on a device is running correctly, because a lot of the simulators and emulators won't have access to it. If you're running an NUnit project, you're actually running a class library within the IDE. It's not going to have access to the device capabilities. So NUnit Lite fills that gap and allows you to test that information. All right, so we've got our test Android capabilities. I'll just set that as the startup project. I'm just going to double click and make sure I've got an appropriate framework selected. I'm going to select Android 4.4. I'm going to run this in the Xamarin Android Player. And Xamarin Android Player right now supports up to Android 4.4.2. Although I do have Android 5 installed on this system. So we'll wait for that simulator to run. And after that's running, we'll go ahead and run the NUnit Lite project. But having a look at the code while it's loading up, you'll actually see that the main activity is not an Android activity by default. It's actually the test suite activity, which is an activity subclass, which has all the information on how to run the unit test, and also how to display the information about the unit test as well. So it just has a single method here, add test, which basically processes the current assembly and gets all those classes, which are the attribute test fixture, and finds all the unit test methods as well, and then adds them into the test suite. So we should have that player running now. Good. We'll switch over to the Nexus S and go ahead and run that unit test project. So you see the code here within the generated template. There's a setup process, a teardown process as well. So the setup is done before all unit tests in that class are executed. And teardown is the reverse. And then we've got a test here that'll pass. There's a few others that'll fail, be ignored, etc. So this is the test harness that we have for NUnit Lite for Android. So I can click on the run tests, and it'll run through the test, and it'll tell me what passed, what failed, what was ignored, and what was inconclusive. So I can click on those results, drill in. I could look at the one that failed, for example. Have a look at its capabilities, run it again if I need to, maybe debug it while I'm doing it as well. But that gives you an idea of how you can use NUnit Lite. takes us through to our first individual exercise. And in your lab project, you'll actually find this listed as exercise 2. Exercise 1 was the initial demonstration. So within this particular exercise, well, you'll be creating unit tests and integration tests, and also have an idea of what it might look like to actually break apart a project so you can test more parts of it. We're actually using an MVVM implementation of the PhoneWord application. So you can actually see how the view models are created so you can test parts of the user interface functionality within code as well. If you're interested more in the MVVM style of applications, we do have a course on using Xamarin Forms with MVVM. But this exercise should take you about 20 minutes. So pause the video, and when you come back, we'll review and go through the exercise. Okay, good luck. Okay, so let's have a quick review of this particular exercise. Now, the main purpose was to actually create some unit tests. And you'd actually have a look, if you have a look at this project, you'll see that it's the PhoneWord application, but it's not the PhoneWord application that you're probably used to. In fact, there's many more projects in this solution than what we've used in the Introduction to iOS, Introduction to Android, and Introduction to Xamarin Forms class. So the PhoneWord application here is actually primarily defined in the PhoneWord core portable class library. And the reason for that is because it's actually using view models. And we've got some view models that are running within the system, mainly because we want to be able to test the user interface aspects of the application. Now, view models are very useful for that. Now, normally, if you've got a class that has user interface aspects in it, the visual elements, as well as the functionality, you can't unit test that because you have to hook into the visual controls. If you separate that out into a view model, you can actually test the actual working parts of that particular view instead, which is a very effective tactic for more thorough testing. Again, have a look at the MVVM and Xamarin Forms class to learn a little bit more about that. But we've got our PhoneWord core project. It's got some services. We've got an interface iDialer. Obviously, we can't use the phone system from the unit test. So here we're actually defining an interface called iDialer that we're going to mock. So mock means to simulate what that particular interface will actually do. And we do that a lot when we're testing, because often we want our tests to run quickly and not actually do the real work, but we want to make sure that it appears to do the real work as well, while still keeping our test run times fairly short. Now we've also got our view models here, which have the functionality. So we've got a phone translate view model, which has some commands that's being executed. It's got some properties exposed like the phone number text, the translated number, the call button to display. And we've also got our PhoneWord translator here, which will convert a phone word such as 1855 Xamarin into its numeric equivalent. We then have our platform specific apps. So this is the Android application for PhoneWord. We've got the iOS application as well. And then we've also got our unit tests as well. So we've got our test of translation. So you can see here we've got a test fixture attribute on this class. We're testing the translation, and we're also testing the Xamarin phone number as well. So this method should be more like check for equality. Should be true. So here we've got our original number, we've got our expected number. So this is the numeric version. We're performing the translation. So this is our arrange aspect. Here's our act aspect where we're doing the work. And here's our assert aspect where we're checking that the expected value matches the translated value. We've also got our view models that we're running tests on. So we've got some setup process where we're creating a mock dialer. So the mock dialer allows us to simulate the process of making a phone call while not actually making the phone call. So rather than wait 15 to 30 seconds just to actually dial, hang up and go through that process, we just say, well, we dialed. You're going to assume that works. And you'll find that'll happen from time to time in your application, especially when you're connecting to very expensive services. And I mean expensive in the scope of time. So if you're connecting to a network service and it takes 30 seconds to a minute, if you've got 20 of those calls, obviously you don't want that to impact the timings of running your test suite. So here we've got some setup. We're actually testing the translation on empty text. So we're setting the phone number text there. We're checking that we can't execute the translate option at that point. So we're testing the view models. And there's other unit tests here as well. We're checking to see that a number will translate using the view model. And once you've got the unit test checking against the view model, you can actually be comfortable that the code that the presentation layer is using to actually perform the user interface actions is going to work successfully too. Okay, so that covers the aspects for that individual exercise. Now, as always, if you have any questions after watching this video and you want to get back to me, feel free to email me at glenn.stevens@xamarin.com, and I'm happy to discuss that further with you as well. Now that takes us to our second flash quiz of the day. And as this is a recording again, we're going to use the honor system. So we'll ask a series of questions, wait about 10 to 15 seconds, and then show you the answer. All right, let's start with the first question. So what are some aspects of unit tests? And just answer all that apply here. The answer here is arrange act assert. All unit tests have that. B, unexpected exceptions will cause the test to fail. And E, they should be as small as fast as possible. The incorrect answers C and D. C should always use the assert R equal operation. That's not true. There's plenty of assert methods that you can use instead. D, they should test integration and database connectivity. Well, they don't have to. You might be testing some internal class functionality. All right, question 2. NUnit Lite is A, a framework for small applications, B, a framework for running tests on device, or C, a testing framework with fewer calories. And the answer here is B. It's a framework for running tests on devices. Okay, question 3. A test that checks to see if a previous feature will work within the application is what kind of a test? Is it a unit test, a regression test, an integration test, or an acceptance test? And the answer here is B. It's a regression test. So that takes us through the end of the content for today's class. We've covered in this objective the types of tests, unit test mechanics, and working with NUnit. But overall, we've introduced you to the concepts around unit testing, the process that you would go through as a developer. Hopefully, we've given you some hints on how to improve your workflow with unit tests also. Thanks for coming to today's recording of the Intro to Test video. We'll hope to see you again, hopefully on one of the face-to-face classes. Happy coding, everyone.